All right, we are now going to skip ahead to section 3 and we are going to talk about inverse functions. We will do a little refresher about what an inverse function is, but a reminder that inverse functions undo each other. And to find an inverse function, you switch x and y, then solve for y. Also remember, inverse functions are reflected over the line y equals x. So if AB is on the graph, then the inverse has BA. We just swap the x's and the y's. So inverse function only exists if the function is 1-to-1. And if f is strictly monotonic on its entire domain, then it is 1-to-1 and therefore has an inverse function. All right, so strictly monotonic, remember, means only increasing or only decreasing. If it's only increasing or only decreasing, then it must be 1-to-1 and must have an inverse. It also, remember, is not 1-to-1 if a horizontal line crosses it more than one time. So continuity and inverse and differentiability of inverse functions. F is a function whose domain is given. If it has an inverse, then these are true. If f is continuous, then the inverse is continuous. If f is increasing, then the inverse is increasing. If f is decreasing, then the inverse is decreasing. If f is differentiable, then the inverse is differentiable. And then the derivative of an inverse. If f is a function that's differentiable on the interval and it has an inverse function, then the inverse function is differentiable and the derivative of the inverse is equal to 1 over the derivative of the original function at the inverse, as long as that's not 0. Let's take a look at what that means. We have f of x equals this function. Now I could find the inverse, but let's try to do it a different way. I start by finding the the value of the inverse. That's what this means when x is 3. That means that the y value of the original function was 3. So I could say 3 equals 1/4 x cubed plus x minus 1. To do that, I gotta get a little creative. I would subtract that 3 over. And then I would probably just graph it. So if I take my graph, I say 1/4 x to the 3rd power plus x minus 4. Graph it. Oh, I can see it crosses right there about 2. Let's find out if that's actually it. Find my 0. Where's my cursor at here? There we go. And there we go. And oh, it is at 2. So that means the value of f inverse of 3 is that original x value of 2. The value of the inverse prime when x is 3. Well, let's find the derivative of the original function. Bring down the 3. I have 3/4 x squared plus 1. I know that the inverse prime of x will equal 1 over the derivative of the original at the inverse. All right, what's that mean? If x is 3, I need 1 over the derivative of the inverse of 3. The inverse of 3 was 2. So I need 1 over the derivative at 2, which is 1 over, if I plug in 2 here, I get 3 plus 1, which is 4. So that means the derivative's value, the derivative of the inverse at 3, is 1/4. It gets very, very wonky. Find the inverse value, plug that into the derivative of the original, 1 over that. Let's try another one. We're going to show that the slopes of these two functions are reciprocals at each of these points. So let's find the derivative of f of x is 2x. And the derivative of the inverse is 1 over 2 square root of x. All right, at 2, 4, the derivative of 2 is 4. Cool. The inverse's derivative, when x is 4, is 1 over square root of 4 is 2, 4. Oh, look, those are reciprocals. Let's try the same thing here, 3, 9, and 9, 3. The derivative at 3 is 2 times 3, which is 6. The inverse derivative at 9 is 1 over 2 square root of 9, 6. Oh, look, reciprocals, they are just the flipped over versions of each other. So you're going to have an assignment on this. A big thing that's going to happen on this assignment is that you'll be told, okay, f of 2 equals 7. And it'll tell you that the derivative at 7 is, I don't know, 8. Why not? So if I want the inverse derivative at 7, I'm sorry, we'd get the derivative at 2. There we go. The derivative at 7 is 1 over f prime of the inverse at 7. Well, the inverse at 7 would be 2. So it's 1 over f prime of 2, which, hey, look, we know what f prime of 2 is. It's 1 over 8. So it's going to line up like that if it gives you those numbers.